Okay, so now let us start the lesson. Do you remember if we were talking about this medians in a triangle? So what we actually learned is that if I have a triangle ABC, and if I draw one median, means that I find the midpoint exactly, let me call it M, and then I connect this to that. This is one of the medians of this triangle, and every triangle has three medians, yes? And then we learned that if I draw another one, for example, I find the middle point here exactly, so let me call it N, and then when I connect this to that one, I have another median. I told you that they intersect at some point, let us call it G, for centroid, yes? And then we proved something. We proved that each one of these two medians will be bisected in a nice way by this point, in a way that this length is 2 times larger than this length, and the same is true for this one. This length would be 2 times larger than this length, yes? So that, if you remember, we showed that this is indeed the case. Before continuing any further, can you tell me what is the relation between the area of this triangle BGM and the triangle ABG then? So we learned that AG is 2 times GM, and then we learned that BG is 2 times GM. Yes? Now my question for you is that if I call this area, I don't know, I will write and then clean it, okay? So if I take this area to be S1 and the area here to be S2, what is, if there is, any particular relation between the area S1 and S2? Yes?
Wasn't S2 twice as big or something?
No, we didn't talk about this, but you are right. S2 is twice as big as S1. But why is that? Last time we talked about this, I told you that if I have a median, if I draw the median, then if I call this one S1 and this one S2, S1 is equal to S2 exactly. This we talked about last time, if I am right. Okay, and I told you why is that the case? Because if I ask you what is the area of this triangle, you have to draw, for example, one of the altitudes, for example, say this one, and then you would say that this multiplied by that divided by 2 is the area S1. And if I ask you what would be the area S2, I hope that you agree with me, this blue line also plays the role of altitude for S2 as well, simultaneously. So you take this blue one again, and you multiply it by this and then divide it by 2. But because this is the median, these two are the same, so the sizes of these areas are the same. But this is not exactly that, but that's actually related to this kind of argument. So, for example, let us discuss this situation that I have a triangle and I just draw a random line, not just a median. For example, let me just take this one here and I will write this. Okay, and I tell you that the relation between BM over MC is, for example, alpha over beta. It's similar to what we had, but that's not exactly the case. Now I am talking, so in the previous example, if you remember, we had something similar to this, but I asked you to write vector AM in terms of vector AB and AC. That was a problem that we completely solved. But now I'm asking a different question, which is not related to vectors at all. I am telling you that assume that alpha and beta are positive numbers, and then I know that the ratio of BM over MC is just this fraction. And I am telling you that if this one is S1, and this one is S2, my question for you is that what is S1 over S2? What is the relation between S1 and S2? Actually, you partially answered that for this case, but let us consider it for the general case. So what would be S1 and S2? Let me write the question mark. So the question mark is equal to, if I ask you what can you write for S1, you say that let us consider this to be the base of this triangle. So this becomes 1/2 times the base times the height. So if I want to draw the height or the altitude, this one, so I will just imagine this line. I hope that you agree with me. Let me call it H for height. And this would be the altitude for this triangle, yes? So I multiply it by H. Now I ask you the same question. So instead of S1 that you see here on top, I wrote this one, which is completely valid. And then I want to do the same thing for S2. So it would be 1/2 the base. This time the base is MC. And then I have to multiply it by the altitude. But the altitude is again H. Yes? So I write H. And then what happens? This 1/2 and this 1/2 are gone. Whatever H is, it is cancelled. And what is left for me is Bm over MC. But what is Bm over MC? According to the problem, it's alpha over beta. So this question is marked, you can just write it alpha over beta again. So if you divide this base by the ratio alpha over beta, the sizes of these areas will be exactly the same, alpha over beta. Yes, is that understandable? Now, why actually you answered it correctly. So try to look at this problem. Take this one to be the base of S2 and this one to be the base of S1. We just showed that AG is 2 times larger than GM. So according to what we argued here, this area S2 is also 2 times larger than the area of S1. Is that understandable? Is that clear? So that's something good to know in passing, because then I will complete this. Okay, now we don't need this. Now, do you remember I told you that the very important thing is this. If I take the middle point of AB, so let me call it P, and then I take my ruler and put it next to this point and that point in order to draw the third median. So it is no longer under my control that this red line is passing through G or not. Because what I am doing, I'm just connecting C to P, and then I do not have any control on the points in between. They pass from any points that they desire to, yes? But then I want to tell you that no, it is not a coincidence. It definitely passes through exactly G. And then this means that the medians of any triangle are concurrent. Concurrent means that they are passing through the same point. Okay? So what I'm saying is that if I just connect this one to this one, automatically it also passes through this point G. But why? There should be, we have to have a good argument for that. That is not just a coincidence. This always happens. So if you don't mind, let me clean this, not to disturb us. Okay, this might be a little bit hard to explain. I want you to fully understand that. So let me just try to draw this picture again. So assume that this is a copy-paste of those parts of that picture. Of course, it is hard for me to do that. I want you just to understand what is going on. So for example, pretend that this is exactly the same picture and just concentrate on AM. Okay, if I ask you, without looking at the other medians, can you tell me where the center of gravity, where the centroid is, where G is? If you want to find G, you really don't need to have other medians involved. Of course, if you have two medians, wherever they intersect, that is G, that is one way. But using this information, you can also find G, yes? How do you find that?
Divided into
Three Ks, and then the one which is closer to M is G, yes? So what you do, you divide this into three equal pieces, for example, and the one which is closer to this midpoint is called G. Okay? So, but we showed that AM and BN intersect exactly at point G. Okay? So, where this BN is supposed to pass? Yes, it should pass at a point. So if I consider two arbitrary medians, so let me just clean this one and then draw another arbitrary median. Yes, so this is midpoint, this is midpoint. So we showed that they intersect at a point with this property, that the distance from that point to the corresponding vertex is 2 times larger than the distance of that point from the midpoint of the opposite side. Yes? We showed that that is actually true. But do you think, now let me just clean this one, and I want to draw G, okay? So that I want to draw CP. So, assume that you don't know it is passing through G or not. But you still know that they will intersect at a point so that the distance from this point to this is half of the distance from this point to that. Is that understandable? So it is not something particular. So if you remember, if you go back and review, what I told you about median AM and BN can be exactly repeated for median AM and CP. If you go and see that proof, I can just copy and paste more or less that proof with changing the letter B to letter C and changing letter N to letter P. I can rewrite that proof exactly again. So it means that these two medians, this black one and this blue one, intersect at a point with that property. For the same reason, these two medians also intersect at a point. Let us pretend that point is G prime. What would be the property of G prime? It should be the case that G prime till A is 2 times larger than G prime till N. Yes? Is that understandable? Yes or no? Yes. But this means G prime is the same as G, because G prime and G are lying on the same line segment. Both of them have this property that the distance from G prime to A is 2 times the G prime to M, and G to A is also 2 times G times M. Yes, we know this should happen. This has already happened. So if you compare these two, G and G prime has to be the same. Yes? Is that understandable? If you don't exactly believe in that, we can probably divide them. And then, for example, how can we continue more? G prime A G A. So if I yes. Do you remember I told you that we can add these? Do you remember? If I have a fraction, two fractions equal, if I add the numerators and I add the denominators, they remain the same. You remember we had one property that if A over B is equal to C over D is equal to K, if I add the numerators and I add the denominators, make a new fraction, the value of the fraction is still the same K. So if G prime A over GA is equal to G prime M over GM, this value is also equal if I add the numerators and add the denominators. But what is G prime A plus G prime M? What is that? G prime A plus G prime M is AM. And can you tell me what is the denominator in this case? Again, AM. So this means that this fraction is actually equal to 1. And it means that the numerator is equal to the denominator. So I have a point G prime on this line. I have another point probably G, but the distance of G prime to A is exactly equal to the distance of G to A. So this means G and G prime are the same. So it means that the intersection point between these two would be exactly the same as the intersection point between these two. So they are actually passing through the same point. Is that understandable? Yes? So, but that is a very, very nice and important feature to have in mind. So if you have three medians, they all pass through the same point, and that is the centroid or the center of gravity of a triangle. Okay. And now that there is also another nice property. If this area is S, this area of this small one is S, what would be the area of this one? This one. The same, yes? Because this is the median for this one. Yes? And now I am asking you another question. So if this is, so let me call this one S1, this becomes S1. If I call this one S2, the area, this one also becomes S2, agree? Because now this is the median here. Yes? And then if I call this one S3, this one is also S3. But it's more beautiful than that. Why? Do you remember I just told you what was the area here and Kevin answered. What is this area? How this area is related to this area? It's twice. So it means that if I add S3 to S3, yes, which becomes the area here, it is 2 times larger than the area here. So it becomes 2S1. So it means 2S3 is 2S1. So it means that S1 and S3 are actually also the same. So instead of writing S3 to make trouble for myself, I can write S1 here. And for the same reason, I can argue the same thing, I can write S1 here. So it means that all the areas are actually the same. If you draw the medians, you get 6 triangles. They are probably not congruent at all. They cannot overlap exactly in general. But whatever it is, the areas are all the same. So you divide the area of the triangle to 6 equal pieces. Yes, that's good to know. Okay. Let me try to solve some problems. So there is an important theorem, so let me clean this and then redraw it again. So assume that I have a triangle, ABC. There is a very nice property of the centroid when it comes to vectors. So let me just draw all the medians here again once more. So this is the median, AM. So this is the median, BN. And then this has to pass through this one. If I draw it precisely, and this would be G, and this, let me call it GP. Okay, there is a very nice property here that let me ask you this. If you have this vector from G, from the center of gravity to this vertex, this becomes a vector. My goal is to add this vector to this vector, which goes from the center of gravity to this vertex, and I want to add the third one to it. So I found the center of gravity, the centroid of this triangle G, the point of concurrency of the medians, and then I take that point and then make these 3 vectors to the vertices and add them. But the answer would be the 0 vector. Yes? So the answer would be the 0 vector. So I want to call it as a theorem. I want you to know it, or actually the 0 vector theorem. So let me write it properly. So G is the centroid of the triangle ABC, then, so if, then GA plus GB plus GC is equal to the zero vector. Okay, let us check why this is true. This is a really important property of that. Okay, how can we prove this, do you think? It's very, very simple. If you remember what we had before, I want to remind you, something you shouldn't forget in mathematics, otherwise your solving abilities would be actually very limited. So do you remember we had something like this, and I expect you to answer me more or less immediately. If this is the median AM, if I consider this as a vector, and then let me consider this as a vector, and this is a vector. Do you remember what was the relation? It was very famous. What was the relation for AM?
AM is equal to 1 over 2 AB plus AC.
Yes, the sum of these two vectors, yes. So whenever you have this situation, that you have a triangle, and then you have the median of that triangle, this as a vector is the average of these two vectors, adding them, dividing by 2, okay? So if I go back to this picture, let us concentrate on this triangle. Let us concentrate on this triangle first. Yes? Do you agree that GM is also a median for this hatched triangle? Yes? It was a median for the bigger one, so this means this is in the middle, so it doesn't matter. This is also a median for this hatched triangle. So you can tell me something. You can say that if I add, so if, how can I write GM as a vector?
1 over 2.
1 over 2
Parentheses.
yes,
GB
GB
plus GC.
GC, exactly. Understandable for everyone? Okay, and then let me multiply everything by 2, so this becomes 2GM is equal to GB plus GC. But you really don't need to work hard, because you know this length is half of this length from length point of view, one thing. Another thing is that you know that they are on the same line, so they are actually parallel. Okay, but what can I write for this one then, according to the theorem? Because we know that this centroid will divide this median into two parts, so that the length of this part is 2 times larger than the length of that part. And I am just now multiplying GM by 2. Can you tell me what vector I can write below that? But be careful, make it 100% correct. Yes, Kevin?
2GM should be equal to either you write minus GA,
yes,
or you write AG.
Yes, very good. This minus sign is critical. Yes, thank you very much. So, very good. So here, let me just follow you. So GM is pointing to this direction, and 2 is positive. So when I double it in size, it cannot be equal to GA, which is pointing upward. Yes, but it is exactly equal to negative of GA. Yes, so this I want you to understand. So you can write negative of GA is equal to GB. So this was crucial. If I hadn't shown you the previous theorem, I was not able to replace this by that. The reason that I could do this, because I know that this is 2 times larger than this one. And then you just need to move this to the other side and you are done. Yes? So then you move this to the other side. It becomes positive GA, positive GB, positive GC. Oops, GB and GC. And what is left on the left-hand side? Of course, 0 vector. But instead of writing 0 vector is equal to this, if you don't mind, let me write this one is equal to the 0 vector. And then we have this one. Yes? Is that clear? Okay. So I really want you to at least be familiar with this theorem. It is very handy when we continue. So whenever I call something theorem, I want you to at least know it's more important than the other statements. There is also a very nice property from vector point of view of this centroid. If I choose any point on the plane or even in a space, it doesn't matter, okay? And if I take this point, for example, let us take it in a space, and then I take this point and connect it to this A, and then this point and connect it to this, and then this point and connect it here, and then this point and connect it here. There is a very nice relation between these four vectors. Of course, it might be not easy to guess, but might be you have some guess. So do you understand what I mean? I can take another point, either on the plane, it doesn't matter, it works, or even I can take it outside. And then let us call this point O. I connect this point O to A, make a vector OA, vector OB, vector OC, vector OG. I have four vectors. There is a very nice and beautiful relation between these four vectors. Can you have a guess?
From the point, the vector from the point to the centroid.
Yes.
4
It is what?
times 4. Four vectors.
No, you are close, but 4 is not the case because one of them is itself. Yeah, it's a very nice relation. This vector OG is the average between those three vectors. Okay, so we want to show that. So this was, let me call it part 1, part 2, for any point O, we have OG is equal to 1/3 of OA plus OB plus OC.
It should be 2 OG because the vectors OA, OB, and OC is equal to OG, and we already have OG.
We don't know
itself.
Why do you say that the sum of them are equal to OG?
I feel it.
No, you mean the vectors are equal? No, because for example, if this is O, when I connect it here to that one, and when I connected this to this one, they are not equal.
No. I'm saying that OA
Yes.
plus OB
Yes.
plus OC
Yes.
is equal to OG.
No, in this case it is not. It is
is
3 times larger than OG.
Okay.
Yes? It's not equal to OG. And I think it shouldn't be hard to realize. I don't know. Can you imagine? It's good to have this imagination. Because, for example, just consider OA and OB. Yes? This is OA, this is OB. If I want to add them, I need to make a parallelogram which goes inside the board. And then I need to find the other diagonal which points inside. Do you understand that? Do you agree that? Just by imagination, from O to A and from O to B, this would be something like this, for example. And if I want to add them, I have to complete this parallelogram. But one part of this parallelogram, if you imagine, it will go behind the board. So this diagonal will actually penetrate behind the board, yes? So this would be longer. And how much longer? If you add the third one to it, it becomes 3 times larger. Not only the length would be 3 times, but if you add them and make those parallelograms, they would be lying on the same line. That's very interesting, yes? This might be, we can do some GeoGebra later to see that how this works. This is very nice to see it from that perspective as well. I think you can go to the 3D graphics in GeoGebra and try to visualize this. That would be also a very good exercise. I will practice on that. Might be next time I can show it to you there. But why this is correct? These things seems very hard to prove, but they are simple. So it was not at all hard, yes? It was very simple. Just knowing this fact was the important thing. So how can I prove this one? It's very simple. I start from this one. So we learned that GA plus GB plus GC is equal to O. I want to teach you some kind of how to think about this problem. So you have already shown the validity of this equality. Okay, so how many points are involved here? A, B, C, and G. Yes? Of course, vector 0 is just vector 0. But if you look at the relation that you're supposed to show, how many points are involved? I just want to tell you how to think in these problems. Otherwise, it becomes very hard. How many points are involved?
4 points.
4 points. So 1 point is missing. Which point is missing? O. I have to bring in O. But there is one standard way to bring a point into the problem in vector equations. And that is what? Do you remember? I told you that if you have any vector AB, if you want to bring in a point, you can bring it, but you take it with the final point and subtract it the same point with the initial point. So this is why I emphasize on that, even though this is trivial, but it is important to know. So whenever you have a vector, but for some reason, like this, you need an extra point to be in the problem, one way to think about is just using this very simple argument. Yes? So for example, I want to bring O in the problem. So what can I write for this one? I can write O with the final point minus O with the initial point. If I ask you what is the result of this, it should be a matter of seconds for you by this experience to say that this is exactly this vector. Is that understandable for you? Okay, I will do the same thing here. So it becomes OB minus OG, and the same thing for the next one, and the problem is solved, isn't it? You see, as simple as that. Because how many minus OG minus OG minus OG is minus 3OG. I move it to the right side, it becomes positive 3OG. And what is left for me? OA plus OB plus OC. So you see, it was not easy, it was not hard at all, but if you want to imagine drawing, it is really hard to imagine. Yes, so that is the power of this kind of mathematics. And then you divide by 3, you will get that number. Yes? Is that clear? Okay. Let me, because the lesson is finished, and we can actually add one more topic to it. But I want to solve one problem for you from two perspectives. One from geometrical point of view, and one solving the same problem using the vectorial method. Okay? So I want you to feel this connection. So first of all, if I just let me just recall you a little bit. If I give you 3 lines randomly, 3 line segments, I don't know, for example, just randomly draw 3 line segments. Do you think using these lines, assume that they are rigid rods, I can move them around, do you think that I can make a triangle? You should be able to elaborate on that. You should tell me how I should know this is working before doing the experiment. Anyone else? Is the question clear? I give you 3 sticks, I don't know, 3 pieces of rod, and then I ask you, before trying to see that if you can make a triangle using them, I give you a ruler and I ask you the same question. How do you know that this is in principle possible? Yes?
The sum of 2 of them should be greater than this.
But you have to check this for every 2 pair. Yes? So you say that I take my ruler, measure this one. So let us say this is A unit length, and this is B length unit, and this is C length unit. I add A plus B, it should be greater than C. I add A plus C, it should be greater than B. And I add B plus C, it should be greater than A. If all these inequalities are satisfied, then I really don't need to do the experiment. If I do the experiment, it actually works. If at least one of them fail, it means that I cannot construct any triangle out of these 3 rods. Yes? Do you remember we talked about that before? So just let me test your memory. How this is expressed in vectorial form. There was a condition. So let me ask you, this was about, so I give you now 3 vectors. So what is the difference between 3 vectors? You are not allowed to change the you are not allowed to rotate it, because if you rotate it, what happens? You are changing the vector. So now if I give you three vectors, one here, one there, one, I don't know, here, how do you know that if I start bringing them close together, then suddenly I get a triangle? That was a relation, we showed that. Is the question clear? So I have three vectors, I can just parallel transport them. I am not allowed to change the size, I am not allowed to change the inclination. I want to bring them, if possible, I can move them around, but I have to parallel transport them. I can, for example, put this one from here, or if I want to, I can put this one from here. If I do that, then the third one should come in. For example, in this picture, yes, it is clear that they cannot make it in a triangle, but I am doing the experiment. But assume that I am not allowed to do the experiment, I just want to see, yes?
For example, if A and B, A plus B is C.
No, a little bit mistake. Not equal to C. If you go back to your notes, you should be able, this is important, yes? Remember it. This is a recap for that. A plus B plus C should be the zero vector. So what you said A plus B should be equal to C. No, A plus B plus C should be the zero vector, means that if I move it to the other way around, so then it means that, so if this is if this is the case, then let me see. Yes, if this is the case, then the line segments whose lengths are these three vectors can form a triangle. So if you go back, we had this before. Yes. So if yes, we had this before. Yes, we talked about this. I don't know if you go back to your notes, you see somewhere when I was talking about the triangle inequality in vector notation. So we talked about this. Okay, so for example, if I have the centroid of a triangle, if this is my triangle, so if this is the centroid, do you remember we just showed something? We showed that GA plus GB plus GC is 0. So it means that I can construct a triangle with these, yes? Pardon?
Are you recording?
Yes?
Okay. If I get too loud, stop.
No problem, yeah. Yes. So GA plus GB plus GC is equal to the 0 vector, we showed that there. So it means that we can construct a triangle using those lines with those lengths. Yes? So it is interesting. So you just start with a triangle, you just draw the medians and then find the centroid. Using the centroid, you have three other line segments. Because of this, that this is 0, you can always use this and make a new triangle. Yes, the triangle with those things. Of course, here you can just parallel transport them. So you bring this here, and then you bring this here. This would make a closed triangle. Yes, this is always possible. So that's a very nice, interesting way of doing it. Now I want to ask you another question. There is a very nice question. Do you think this can also happen with the medians? So my question is that, by the way, this is the standard notation we use for the length of each median. We show it with M, but we equip it with some index, A, B, C. M sub B means the length of the median corresponding to the side A. So MA is the length of this median, and MB is the length of that median, and MC is the length of this median. Now my question for you is this. Do you think that the medians of a triangle also make a new triangle? So I have a triangle, then I draw the medians, so I have 3 line segments in my hand now. My claim is that using these 3 medians, you can make another triangle, which is not trivial now, yes? So let me give them names here, AM, BN, and CP. And this is, if you want to, that's the centroid. So what if I want to show it geometrically, you need to be creative. If I want to show it geometrically, I need to convince you that the length of AM is smaller than the sum of the lengths of these two. And I have to repeat this argument for the length of BN with respect to the other two lengths and the length of this one with respect to the other one. This is the geometrical way. Yes? That's also interesting, not hard, but you need to be creative to add some lines to this one to be able to continue your reasoning. Yes? But using vectorial method is actually very simple. What can I do? I want to show that if I can show that AM plus BN plus CP is what? Is 0, then I am done. If I can show this, I am done. Yes? But you know, what can I write for AM? What can I write? AM is the median, so I can write AB plus AC divided by 2. Yes? So the left-hand side is equal to. And then instead of BN, what can I write? I can write BC, 1/2 BC plus BA. And then instead of CP, I can write what? 1/2 CA plus CB. Yes? So instead of, so this is the question mark. If I am able to show that the sum of these three vectors is the 0 vector, it means that using those line segments, I can construct a new triangle. But this is finished. Don't you see that? Because I can factor a 1/2 2 out. What is AB plus BA? This is the 0 vector. What is this one with that one? The 0 vector. And what is this one with that one? That's the 0 vector. So it becomes the 0 vector, the 0 vector, the 0 vector, so it becomes the 0 vector. So you see that I could actually solve it actually very simple. But if you want to understand and appreciate the power of vector method, even for geometry itself, okay, is to try to convince yourself without using this method. It's not hard at all, but let me just make it open. But let us remember to solve it next time together, okay? Is that clear? Okay. Then let us see what is left. Nothing that much. Let me ask you some questions, test your understanding, even though, so this is also very important. So I give you a picture here. I give you this vector A, and I give you this vector B. Apparently, you see that I have drawn them in a way that they are not parallel. But I write this for you. I write X and Y are numbers in my head. You are supposed to find my numbers, which are in my head. But I give you a piece of information. I tell you that X times A plus Y times B is the 0 vector. By the way, be careful about this. How many equations you see? There is one equation because you have one equality sign. But how many unknowns you see? You see two unknowns. Is it possible to find the two unknowns simultaneously here or not? So what I have drawn two non-parallel vectors on the board, and I tell to you that I have chosen two numbers in my head so that when I multiply x, the number x by A, and I multiply number y by B, I make new vectors. When I add them, it happens to be the 0 vector. What are those numbers in my head, x and y? Yes?
0.
Exactly. Can you tell me why?
Because
Both of them has to be equal to 0. It's very, very important. So let me just write this one for you here.
times any vector is the zero vector, and then that becomes.
So this is one condition, but so the way that you thought it was the other way around. You found the numbers, but so let me ask you in this way, are these the only numbers? X equal to 0 and y equal to 0 will definitely work. Because if instead of x I put 0, instead of y I put 0, I get 0. But let me modify my question. Find all possible values for x and y. Then what is your answer? Do you think that you can still find a number, non-zero number, that's why that? Yes, Dennis?
It's because they're not parallel.
No, so you agree that we can find other numbers or
No,
not?
we can't find.
We can't, yes?
Because if you add two vectors, they have to be parallel to get to the zero vector unless they are zero.
Yes, so your intuition is correct. But if you want to make it rigorous so that no one can doubt, my claim is that both of them have to be equal to 0. Let us use proof by contradiction. You say no. What does it mean? It means that either none of them is 0 or at least one of them is not 0. Okay? So let us assume that one of them is not 0. Which one do you prefer not to be 0? It doesn't matter that much, yes? So x is not equal to 0. My claim is that both of them have to be equal to 0. You say no, it means that at least one of them is not 0. Let us consider x is not 0. If you don't like it, I can repeat the argument with y, yes? So x is not 0, then what happens? xa plus yb is equal to the 0 vector. I move this to the other side, so xa plus, it becomes minus yb, do you agree? And now because I have assumed that x is not 0, I am allowed to divide by x. So it becomes a, so it's crucial, you see, it's minus y over xb. Yes? So this is a number. This is a vector. I am multiplying my vector by a number. So it will generate a vector parallel to b itself. So what happens? It either changes the size of this vector or changes the direction or both. But it will never ever be parallel to a because the starting points, the vectors were not parallel. So this means that if you assume that x is not equal to 0, you have to agree that these two vectors are parallel in the contradiction with the starting assumption. So x has to be equal to 0. Yes? When x is equal to 0, you put this one equal to 0 and you say that a number multiplied by a vector is equal to 0 and the vector itself is not equal to 0. So the only option is that y is also equal to 0. Is that understandable? So this means we say that, if you go to university in linear algebra, we say that these two vectors are linearly independent. Okay, so it means that, do you remember what was the name of this kind of combinations in linear algebra? There was a name for this. You multiply a vector by a number, multiply another vector by another number probably, and then add the result. That would be called a linear combination of vectors a and b. Yes? So if a linear combination of two vectors is equal to 0 vector, and you conclude that x and y are equal to 0, this is the only choice, then you say that a and b are linearly independent. Okay? This idea, you will work a lot with this idea when you go to the university level actually. But here, if you have two non-parallel vectors in a plane, they are linearly independent. Yes? Yes? So let me, if I want to write it as a remark, if A is not the 0 vector, and if A is not parallel to B, and if XA plus YB is equal to the 0 vector, then from all these you can conclude that x is equal to y is equal to 0. Yes?
It's not the zero vector, just.
Ah, sorry, thank you. This is the zero number. Thank you very much. Okay, so I think that's a good point that we stop here. So whatever is in this first problem set, in principle, you can solve it. Yes? Everything in the first problem set. But the quizzes are different. Quizzes are your exams, yes? Whenever you have time, just respect the due date and then finish it before that. So that I will gather them, of course. If they are really, really bad and you are not satisfied, then I can make an exam for you. But the reason that I want to do it in this way is to get rid of that stress because of the exam and try to enjoy real mathematics here, okay? Any questions? Okay, so let me just stop the video. Do you know when the lesson ends?